before we can complete the square, we got to understand what complete the square even means. And so before I do that example, I'm going to go over here on my scratch paper. Do you know what this means? Is this equal to x squared minus 25? Oh no, minus and minus makes a plus. Is that equal to x squared plus 25? A lot of people think it is, but that is incorrect. X minus 5 squared, doesn't the exponent mean you multiply it by itself? Isn't that what the squared means? And so one way you could figure out the answer is to do a box problem. And so this is equal to x squared minus 10x plus 25 when you solve out the box problem. This is called a perfect square trinomial because you got it from multiplying x minus 5 times another x minus 5. Let's do another example of that. X plus 3 squared. That is not equal to x squared plus 9. That is equal to x plus 3 times another x plus 3. So that's going to be x squared plus 3x plus 9, because I have to combine those like terms. Oh, yes, thank you very much, because when I combine those like terms, that should be a 6. That 3 should be doubled because I added 2 of them that were exactly the same. If I had x plus 8 squared, well, if I did a box problem, that would be x plus 8 times another x plus 8. So that would be x squared plus 16 plus 64, because I would have to add those together. Do you notice those are exactly the same in all of my examples? And they would be exactly the same in any example that I could give you. X plus a squared is x squared plus 2a plus a squared. Whatever this term is right there, right here it's going to be doubled because you're always going to have these two that are exactly the same that you would add together. There are 2 of them. And of course this one is always those 2 multiplied together to get the squared. This is the pattern that we use to be able to complete the square. This is called a perfect square trinomial. Okay, back to my notes for today. If I had x squared minus 8x, what number would I have to put there so that I could have that perfect square trinomial pattern that I was just doing on my yellow sheet of paper? I am going to force my problem to be in this perfect square pattern. What number is that going to have to be? Well, it's not very difficult to figure out. It's b divided by 2 and square it. B is the number in front of the x. What number is in front of the x? Now, it's actually negative 8, but I don't have to worry about the negative because when I square it, it's going to be positive anyway. What's 8 divided by 2? What's 4 squared? Now it has the perfect square pattern. I'm going to force my problem to have this perfect square pattern so that I can rewrite it like this. If I did this out with a box problem, it would be equal to that trinomial. Whatever this sign is, that's what the sign is for my perfect square. Okay, let's try another one. X minus x squared minus 12x. What do I have to put there to make my perfect square trinomial? B divided by 2 and square it. What's the B number? It doesn't matter about the positive negative because when I square it, it's going to be positive anyway. 12 divided by 2 is going to be 6. 6 squared is. So this is going to be x plus x squared plus 20x plus what? What's going to be in this perfect square pattern? What's 20 divided by 2? And then square it. Is it very hard to figure out what that number has to be? You ready for a more difficult one? Why is that more difficult? It's not an even number. So what do you do when you square it? Well, it's a fraction. The way you do a fraction is you square the top number and you square the bottom number. And so this number would be 9 over 4. So it doesn't have to be an even number here, but if this is not an even number, this will be a fraction, because when you divide it by 2, it's not going to come out to be a whole number. Now, we're going to use this perfect square pattern to solve quadratic equations. Let's go back to the example that we have done previously. I'm going to solve this quadratic using this completing the square idea. Now, this number right here has to be half of that and square it. Is it the right number? It's not the right number, and so I need to move that number out of the way. For factoring, for the quadratic formula, I need it in standard form equal to 0. For completing the square, I need the x squared and x term, but the c term needs to be moved to the other side. And now, what number do I need to put in here to make this the perfect square pattern? 10 divided by 2 is 5. 5 squared is... Now I have a whole equation. Over here on this page, I just had expressions. I didn't have an equal sign. On this problem, I have an equal sign, so if I add 25 on the left-hand side of the equal sign, what do I have to do on the right-hand side of the equal sign? I can't add 25 just to one side of the equation. I have to add 25 to both sides of the equation. And then this becomes this perfect square pattern. If this is a negative sign, this will be a negative sign in the pattern. And over here, negative 9 plus 25 would equal to 16. Well, how is this going to help me solve and get my two answers. Well, I need to solve for x. That means I need to get rid of the square. The opposite of a square is a square root. If I square root on the left-hand side of the equation, what do I have to do on the right-hand side of the equation? And the square and the square root cancel each other out. And so this is x minus 5. What's the square root of 16? Why is 4? Because 4 times 4 is 16. But what's negative 4 times negative 4? Isn't it also 16? So this answer could be positive 4 or negative 4. Anytime that you take a square root to solve an equation, it will be plus or minus the square root. So it doesn't take much to finish this. I'm solving for x. I need to get rid of the negative 5. What do? I need to add 5 to both sides to cancel out the 5. You never, never, never leave the answer in this form. If the 5 is a whole number and the 4 is a whole number, you go ahead and continue solving. That's what the plus and minus means. 5 plus 4, 5 minus 4. And you get your two answers. And that would be example number 1. So we have 2x squared minus 8x plus 7 equals 0 for our next problem. Now, on any of those completing the square examples that we did to start, did any of these have a number in front of the x squared? No. So if there's a number in front of the x squared, the first thing we need to do is get rid of that number in front of the x squared. Oops. And so that's going to cancel out the 2. 8 divided by 2 is 4. 7 divided by 2 doesn't reduce. 0 divided by 2 is still 0. We are going to solve by completing the square. If we're going to solve by completing the square, that's not the right number I need to complete the square. So this needs to subtract from both sides so that I can move it out of the way so that I will be able to add my perfect square number right there. Where am I going to get this perfect square number from? 4 divided by 2 and square it. 4 divided by 2 is 2. 2 squared is 4. If I add a 4 on this side, what do I have to do on that side? And so this is going to be x minus, because I'm going to take whatever sign is there, and this number before I squared it was a 2. Uh-oh. What am I going to do over here? Well, to add, do you remember I need a common denominator? What's the denominator? And 2 times 4 is 8. 4 is equal to 8 over 2. So that wasn't too terribly difficult, was it? And negative 7 plus 8. The way you add fractions is you add or subtract the numerator and you keep the denominator. So that is, when I add those two fractions, that's a half. Now, the reason I did all of those strange steps is to get to this point so that I can cancel out this square with a square root. The square and the square root cancel each other out. And this really doesn't reduce any. So, I'm solving for x. I'm going to add the 2 to both sides. And I'm going to leave it like that. There's a little bit more reducing that we can do, but I need to teach you a few more techniques before we can reduce that any farther. So, why I get, the last problem I came out with 2 whole numbers here. Nope, that's not why. Because even with a fraction, sometimes you can get 2 fraction numbers. Yes, because is 2 a number that can be simplified? No. And so that's all I can do there. That is how I'm going to leave the answer. Okay, let's do one more. All right, here we go. I am going to solve this by completing the square. Is that the number that I need right here in order to complete the square? It's not the right number, so I need to move it out of the way. X squared plus 14x plus, I'm going to skip a space so I can come back in and add that perfect square number in there. Negative 6 subtract 42 would give me the negative 48. Now, this perfect square number that I'm going to put in here is going to be 14 divided by 2 and square it. 14 divided by 2 is 7. 7 squared is 49. If I add a 49 on this side, what do I have to do on that side? The reason I did this was so I could rewrite it. If that's a plus, this is going to be a plus. Half of this is 7. And over here I would have a 1. Now that I have a perfect square, I need to square root both sides. The reason I square root both sides is so that a square and a square root can cancel each other out, and I can just get x plus 7. Okay, what's this equal to? What's the square root of 1? Not 1. Plus or minus 1. Subtract 7 from both sides. Do not leave your answer in that form. X is equal to negative 7 plus 1. X is equal to negative 7 minus 1. X is equal to negative 6, or X is equal to negative 8. How many answers was I looking for? 2. And so my 2 answers are negative 8 and negative 6.